In this video, we're going to look at the difference between conditional convergence and absolute convergence. So suppose you have a series. If you look at the absolute version of that very same series, because most of the time the absolute version is easier to evaluate than the original one. So if you look at the absolute version of the very same series and the absolute version converges, there's a theorem that says that if the absolute version converges, then the original series they will automatically converge. So if the absolute version converges, the original will automatically converge, and we say that this series is absolutely convergent. Now, if you have a series and then you look at the absolute version of that very same series, if the absolute version diverge, then you've really wasted your time. It yields no new information. But then if it diverges, you've wasted your time. But then if you happen to be able to use some other tests to determine that this thing converge, then this thing here, we say that this thing here converges conditionally. So let me just reiterate. If you look at the absolute version, if the absolute version converges, then there's a theorem that says this thing here will also converge. So this thing here converges absolutely. If you look at the absolute version, and it diverges, and then you happen to perform some other tests that tells you that this thing here converges, then this converges conditionally. So let me give you an example. So if you look at this thing here, so you've got a series here which you're trying to determine if it's going to converge or if it's going to diverge. You look at the absolute version of this thing, which turns out to be this. But then we know that this thing diverges. So yeah, we know that this thing diverges. But if we use some other tests, so for example, this thing here. If we use some other test, so let's use the alternating series test. Look at the alternating series test says that you should discard this bit, and just look at this bit here. And then if the UN are all positive, which in our case it is, all positive and non-decreasing, and it is indeed heading to 0, we can now confirm that this thing converges. You see, going back to here, as an example, looking at the absolute version of this, it fails. This thing here, the absolute version, diverges. But then we use the alternating test to confirm that this thing converges. So therefore, this thing converges conditionally. Okay, so let me give you another example. Hang on. If you look at this example, look at the absolute version of this. So that will then be this. Now we know that this thing here, because we've seen it many times, this thing here converges. So therefore, there's a theorem that says that if the absolute version converges, then the original series will automatically converge. So this here converges absolutely. Okay. So here's the definition and the theorem that says that if the absolute version converges, then the original series will automatically converge. That's this theorem here. Okay.